Hi everybody! Today we're going to start off on an adventure on divisibility. So as I've worked with a lot of students over the years, I've realized that when it comes to things like reducing fractions or factoring, a lot of students have to go through a certain level of guesswork because they simply don't know the rules of divisibility. So today we're going to start by going through 1 through 10 to learn those rules of divisibility to make such problems as reducing 3,024 over 3,456 easier, or factoring 432x squared minus 96 minus 35. I don't know about you, but if I ran into these giant numbers, I wouldn't quite automatically want to start with, oh, let's divide by 2. That's just going to get big numbers. So let's go ahead and start out and learn how we can make divisibility a little bit easier and reduce the guesswork. So let's start with divisibility by 1. We know intuitively from the property, the identity of multiplication property, that if you multiply anything by 1, you're going to get itself back. So intuitively, we can reverse that and say that everything is therefore divisible by 1. So that's the super easy one. We get it out of the way early. Next, we can move on to the 2's. So maybe you remember back in when you were 5, maybe even 4, and you were counting by 2's. You were counting the even numbers. All of those numbers are therefore divisible by 2. Okay, so 1's and 2's, super easy, out of the way. And now we can move on to the 3's. All right, so let's move on to divisibility by 3's. So the basic numbers that come in your regular 3 times table, 3, 6, 9, all the way up through 30, those you're probably pretty comfortable with. And you might even be comfortable with some of the larger 2-digit numbers, like say 63 or 96 even. But what happens when you move into those 3-digit numbers? Those might not be quite so easy to tell whether they're going to be divisible by 3 or not. Well, there's a really easy trick that you can do, and that is to add the digits of the number, and if the sum is therefore divisible by 3, then we also know that the large number is divisible by 3. So let's see an example of this. Over here I have the number 351. I don't know about you, but I don't know off the top of my head if this is automatically going to be divisible by 3 or not. So let's use our trick. Remember, we're going to add the digits of this number and see what the sum is. So we have 3 plus 5 plus 1, and that equals 9. So 9 is a number that we know is divisible by 3. So therefore, I know that the whole number, 351, is also divisible by 3. Now you might be saying, now come on, Becky, I'm not sure that I'm just going to take your word for it that this rule works. Okay, fair enough. Let's test it out. We're going to go ahead and solve it with regular old long division. Okay? So 351 divided by 3. So 3 goes into 3 once. 1 times 3 is 3. Minus gives us 0. Bring down the 5. 3 into 5 goes once. 1 times 3 is 3. Subtract 2, bring down the 1, 3 into 21, 7. 7 times 3 is 21. No remainder, so we know that indeed 351 is divisible by 3 because 3 times 117 equals 351. So there we have it. We know that this trick works, at least for this 3-digit number. But what if those numbers get even bigger? Maybe a 7-digit number. All right, so we're going to try an even bigger number here and make sure that our rule for adding up all the digits and verifying that that sum is divisible by 3. We're going to make sure this rule still works even for big numbers. So here I have a 7-digit number, 6,531,282. We're going to use our trick to determine if this is divisible by 3. So 6 plus 5 equals 11, plus 3 is 14, plus 1 is 15, plus 2 is 17, plus 8 is 25, and add on another 2, and you get 27. Since I know that 27 is divisible by 3, I can therefore conclude that this large 7-digit number is also divisible by 3. But again, maybe we're not too confident about the validity of this rule yet, so let's prove it to ourselves, okay? Let's try it. We're going to divide. All right, so 3 goes into 6 twice. 2 times 3 is 6. 6 minus 6 is 0. Bring down the 5. 3 goes into 5 once. So 1 times 3 is 3. Subtract, you get 2. Bring down the 3. 3 goes into 23 7 times. 7 times 3 is 21. Subtract, you get 2. Bring down the 1. 3 goes into 21 7 times. 7 times 3 is 21. Subtract, you get 0. So just bring down the 2. 3 goes into 2 0 times. So we get the 0. 2, bring down the 8. 3 goes into 28 9 times. Space. 9 times 3 is 27. Subtract 1, bring down that final 2. 3 goes into 12 4 times. And then 3 times 4 is 12. No remainder. So we know, since there's no remainder, that this number, 6,531,282, is in fact divisible by 3. All right, so from now on, when you run into a fraction that needs to be reduced or a factoring problem and you need to determine if one of those numbers is divisible by 3, instead of guessing, just do a quick sum of the digits, and if that's divisible by 3, then you'll know the big number is divisible by 3. Next up, divisibility by 4. All right, we're back, and now we're going to do divisibility by 4s. The good news about divisibility by 4 is it's entirely observational. There's no arithmetic involved, not having to add up digits or anything. You just have to look at the number. But the question is, what are you looking for? And the answer to that is, are the last 2 digits of the number also divisible by 4 as a number? Okay, so we're going to start with this example over here, 316. So all I have to do to determine if it's divisible by 4 or not is to look at 16, okay? 16 is divisible by 4, so I can therefore infer that 316 is also divisible by 4. Let's check this out and make sure it actually works. So 316 divided by 4. 4 goes into 31 7 times. 7 times 4 is 28. 31 minus 28 is going to give us 3. Bring down the 6. 4 goes into 36 9 times. 9 times 4 is 36. Subtract, there is no remainder, so we can be assured that 316 is in fact divisible by 4. All right, so let's see if this works on a larger number. Here we have 762,932. Is this number divisible by 4? Again, all we need to do is look at the last 2 digits. In this case, it's the number 32. Is 32 divisible by 4? Indeed it is. So therefore, this whole number should also be divisible by 4. Let's check it out to make sure. All right, so 4 goes into 7 once. 1 times 4 is 4. Subtract, you get 3. Pull down the 6. 4 goes into 36 9 times. 9 times 4 is 36. Nothing, so we just bring down the 2. 4 goes into 2 0 times. 0 times 4 is 0. Subtract gives us 2. Bring down the 9. 4 goes into 29 7 times. 7 times 4 is 28. Subtract, you get 1. Pull down the 3. 4 goes into 13 3 times. 3 times 4 is 12. Subtract, you get 1. Bring down the 2. 4 goes into 12 3 times. 3 times 4 is 12, no remainder. So we know that this number, 762,932, is in fact divisible by 4. So divisibility by 4 is pretty easy. It's just a matter of observing. Check out those last 2 digits. Is that number divisible by 4? If it is, then you know the whole thing is. I hope you've enjoyed this quick exploration of divisibilities for 1 through 4. Check out our next video where we're going to explore 5, 6, and 7.